Hey guys, this is a BARKER's Extension 1 Semester 1 past paper from 2012, and we're up to question 11, so we're out of the smooth sailing of multiple choice into the more tumultuous, more murky storm of worked answer sections. Well, that was more dramatic than it needed to be. Anyway, so it's a question to do with integration. And what we're asked to find is the integral, so it's a definite integral because we've got limits, 2 and 1. And the equation is x over x squared plus 1 dx. So first of all, I'm just going to talk about the theory that's going to be used, and then how we're going to apply that to the question. So I've in this yellow box here, I've done it in differential form. So say we've got a function, so log base e of some function. So this could be any function f of x. So it could be 2x, x squared, e to the x, 2x plus 1, any kind of function of x. When you differentiate that log of f of x, what you get is this little function we had, you differentiate it, you pop it on the top, and you get the f dashed of x, and then you divide by just whatever the function was. So it's very convenient, and an easy formula to memorize, and it's you sometimes see in books, you only see the, oh, my pen never works at the start of videos. You see you see this, and it's not very helpful. Log of x equals 1 on x. So the reason why that works is because we've got this function. This is our f of x. In this case, is just x. We differentiate x, we get 1. Pop it on the top. So that's like up here when we've got the derivative on the top, and then we just divide by whatever the function is. But the problem is with this, it's not very general, because this is the one that you want to be memorizing up here. This is not very specific. So this theory is actually going to be used in this question, and what we're going to do is we're going to do a nifty little trick. So we're going to think about, okay, when we differentiate this bottom, this bottom function, we're going to get, so this f of x down here, this function. What are we going to get? We're going to get 2x on top. So that would be awesome if we had 2x on top, because if we had 2x on top, we'd get 2x over x squared plus 1 dx. And the reason why that is so good is because the top is the derivative of what's on the bottom. Because when we differentiate x squared, we get 2x, we differentiate 1, we get 0. So we're in this form where we've got the derivative on top and the normal function on the bottom. Beauty. But you might see the problem. Hang on a minute, you've just chucked a bloody 2 in there. You've got to get that 2 out because you've just totally changed the question. So if we put a half here, it's going to be a half times 2. That's going to go to 1. And we're going to be end up with what we had. So that's what we've got to do. We've got to remember to put this half there so we don't change the question. Now it's just a straightforward integration problem. So I'm just going to integrate. So it's integration going this way. No. It's integration going this way. It's differentiation going this way. So we want to go this way. Integration. So when we've got the derivative on top and the normal function down below, that's going to give this log of f of x. And f of x is just a function on the bottom. So it's just this x squared plus 1. Beautiful. And we've got to remember our cheeky little limits. Beautiful. And now the question's just a little substitution. So now it's from here on in smooth sailing. So half, and then we put 2 in. So 2 squared is 4 plus 1 is 5. Beautiful. Then we subtract, when we pop 1 in, 1 squared is 1, 1 plus 1 is 2, log of 2. Beautiful, so we're there. But the problem is no self-respecting mathematician would ever leave it in that form, because we're going to use that log law where you can pop the 5 on the 2. Because that's a law, when you've got a log minus another log, you can write them in this format here. So our answer, I'll just write it without the brackets, is a half log 5 on 2. Beautiful. And the reason why we don't have a plus c is because it was a definite integral, meaning that we've got this 1 and 2 here, and you don't have to add a plus c in those cases. So I hope that was clear. Not queer. That was an unfortunate mistake of the tongue. And it's just a 2 marker. So, yep, I hope that's clear, and I'll see you in the next video.